근데 해외에서 살다가 왔어요.
저는 고등학교 미국
아, 그래요? 미국 사람도 한국 사람들이랑 하고 영화를 비엘리 같은 데 거기를 쓰요. 그냥 나는 영어도 그러니까 이상한 말을 하는데
와, 딱 전문.
So I see there are 2 viewers. Please join in the Kakao Open chatting so that I can see who is in the class, and also I can accept your question and feedback through there. And unfortunately, I cannot see a chat at the YouTube. I don't know why, but I cannot see that. So please use Kakao to send me a message. 네. 들어오세요. 네. I will talk with our faces on the video for a while, and then I switch to the PPT slide, and that'll be only the voice-oriented one. So at the moment, you can rest for a while. 나도 이런 거 안 해봐가지고 되게 어색하고. 세 명밖에 없네. 문제가 있는데. Okay. Now I have 6 viewers, so let's start the session together. Okay. So in open chat room, I have 4 students, so I think we have at least 6, including you guys. Okay. So let me begin. So thanks for coming, despite the urgent notice of online lecture. So I hope you have doing well, and I hope you are getting over any trouble for the earthquake well. So school is getting fast, quickly coming to the normal status. And I think all you guys and I also, we recognize how precious our daily life is. And I really wish everything going back as usual, or including the software engineering course, including this one. Okay, today I have Wangam with me, and I have, sorry for Songmin with me, for giving me feedback directly, so that your role today is bringing up many questions simultaneously, so that any other guys can get, so that I can aware in which point I need to add up more explanation, or something that I have mistake. I want to have it direct feedback from you. So we have a 10-second or 15-second delay to the listeners out there. So your role is very important. Otherwise, it is hard to make the course interactive. So, okay. So let me begin. So I think you, basically we pause everything for a day, for including today. And then I slowly resume our semester. And then I didn't actually plan, but I turned my mind and decided to give an online lecture, because I want to make the remaining 15th week and 16th week a little bit landed softly. So today I want to give you some announcements. So first of all, your TOM project. So due to the ABIC program, 공학 인증, we got to do the TOM project. It is a part of your whole year's requirement. You need to take you need to accomplish what, 3 or 4 TOM project courses, right? 예, 뭔가 그런 거 있죠. 뭐 프로젝트의 한 과목. So which require you to have a final report at some point. It is a profile, and your portfolio for the ABIC 공학 인증 is maintained, even though you cannot see it. But in our department, we maintain that. So in order to fulfill that requirement, we got to need to have our TOM project done. But I know it is infeasible to do everything that was planned. So I decided to change it, and I will give a more concrete plan as you come back to the campus. However, I can give you an overview for the changed plan. So I changed the TOM project as a pass and fail evaluation. You can either pass on the TOM project or fail. But to pass on the project part, you need to fulfill some requirement. And then I give a detailed description. Very basically, you need to do this activity and this activity and this activity, and that will be documented in your final project, and you will pass.
Is it going to be changed completely? Like, are we still doing the markdown converter?
Yeah, I thought about that part, but if I change the topic to a different one, then you need to restart everything from the design. So I want to keep the topic as the same, and so that you can utilize the first part, the design part, as the part of your final report. And then I will give a pretty detailed description. So my plan is that in last year we used the same topic, but I make a project problem as a little bit of an open problem, so that you can suggest and implement some feature, so advanced features of the Markdown text. However, in this year, I decided to give you a very concrete example, few examples for the Markdown text documents. And if your program properly manage that inputs, then you will pass. So that there is a less chance to make it confusing and it'll be much easier for you to fulfill all those things. And I will give very detailed guide for the program design part. We basically cover the requirement part, and next part is the program design, and I will teach you the visitor pattern. And from there, you can easily follow what to do. And the last part, so requirement design with the visitor pattern, and the last part will be the testing part. And if you fulfill those three parts, then you will pass. And if you miss, you will not directly fail. I will give an extra time upon your request after the 16th week, for like earlier than 17th week, if you ask for the extra time to finish the project.
Assignment was what was given is not count.
It'll be counted. It'll be counted, but yeah, I will not. It'll be counted, but it'll be score either pass or fail. That part was changed. But first assignment is basically the same. Evaluation different, and then I will reduce this planned second and third assignments so that I can moderate your workload for the town project. Any question from the audience? If you have a question, please type in something that on the Kakao. 이쯤 돼야 이제 얘들이 들었을 거예요. 15초쯤 있어야지. 주영, don't you have any question? Or could you echo something on Kakao? Okay, 네, 저 정도로 듣습니다. 네, okay. So I think you don't have any question. So let me move on to the contents part. So we cannot cover everything that has been planned, and so I thought about what would be the best way to spend remaining 2 weeks to wrap up your software engineering course. And I think that I will cover testing part. So I'm sorry that I can't spend enough time to make a full link between design and testing and requirement analysis or the flow. So it'll be a little bit, you feel like the topic is a little bit isolated and a little bit different from what we have covered so far. However, testing is a very important part. So I simply give it to you, and I hope it'll be like a course inside of a course. So it'll be a little bit of different topic from what we had before, but it'll be hopefully fun to you, and definitely it'll be helpful for you. And let's do it. So I will cover testing today, and I will spend most of the remaining time either testing or your term project. So that'll be end of your final exam. And I asked school to schedule our final term, and as you know, the school scheduled the final term, final exam time, but it is not announced. But upon its decision, I will give you a concrete plan for the remaining 2 weeks. Maybe I can give you a 4 lecture on that from the 2 weeks and have a final, or 3 lecture. I'm not sure about that part. Okay. Anyway, let's begin. Software testing. So I will put the slide on the video, and we are fading away. Bye. Okay, do you see the slide clearly? Fonts are right? Tonghui, do you clearly see everything on the slide? Okay, great. So yeah, okay, thank you. So let's talk about software testing. Yeah, this picture gives you a fundamentals of the software testing. So what we have talked so far is a software, how to develop software correctly, efficiently, reliably. That's the basic topics of the software engineering, briefly speaking. And one of the crucial activity in a software engineering is to check whether we really achieve our goal. All the requirement that we had written down or we had identified are fulfilled by developing a software. And we need to have, obviously, due to many complicated and complex nature of the software, it is a very not trivial that the resulting software really fulfill the requirements. So we need to have a strategy. We need to have a very strategic approaches to check whether each requirement is really fulfilled by the software implementation or not. Otherwise, we really cannot guarantee that software behave as we intended or as we expected, even though it looks all right. Yeah, that is a big difference from other engineering principle. I personally see. Let's talk another issue a little bit while. So I personally experience the unique nature of the software recently due to the earthquake. And as you see the earthquake, even though earthquake hit our school, the buildings are blocked. However, buildings are not demolished, right? There's a cracks and we have many damages. However, that huge energy cannot simply break our building at once. That is all right. So we can put a support or jack support and many other things to recover the building up, or we still have a chance to make it work again, because it doesn't really simply goes away, but it continuously and slowly losing its functionality. That is what physical entities are. However, softwares are not. So I'm living in a one room outside. 예, 양덕에 살아요. And our building has a huge damage. So they bring a support and try to they put something to prevent it from having more damage. But what's more problem is software. What software here is a legal issue. So I have a conflict with a house owner, and I checked the legal the laws for the 전세금 and everything, and it doesn't clearly say it about our cases, especially with the earthquake. So we are having trouble, and but that is a software part. And if we have a software part problem, then it simply makes a lot of trouble, and there is no excuse for these exceptional cases. So that is a more problem to me. The legal problem is than the physical damages by the earthquake. And that is the same. Even though in usual cases, your software works all right. However, there is no guarantee that your software really works for every cases to fulfill very detailed requirements, even if we don't really check it working. So software testing is basically checking these things. So let's see this upper part. Okay, let me use a pointer here. Upper part here. So software is created from its design. So software is first created from the requirements. We first identify what is the expectation from the user, environment, and circumstances, and what kind of constraint we need to meet. And to fulfill these needs or requirements, we bring a design. And at some point, we can check that our design is really corresponding to the requirements, so that we have a proper design or not. We didn't cover this issue. However, there is many technique. In high level, we can check design is really corresponding to the requirement or not. So we may have a confirmation that design is go well with the requirement. And from this design and requirements, we make software, working software, or we say we implement the software. And here, implementation is two-folded always. First fold is that design turn into a program with a very low-level code, right? And at the same time, we need to earth down the requirement part as well. Otherwise, we cannot sure this program is really corresponding to behave as expected by the identified requirements. So requirements should be specified into, here I say, test cases. Test cases, you can think that very detailed scenario on a program for a requirements. So still here, we use a vocabulary of the real world and our domain, but it should be turned into the vocabulary of the program. For example, our app, for example, if we have a mobile app, then we say that mobile app should be respond very quickly, so that we have no difficulty to this functionality or something like that. Then it should be turned out into very detailed requirement, like for pressing this button and to the appearance of this message, it should take less than blah blah milliseconds or something like that.
Test cases is something like more specified use case.
You can think of it that way. But use cases, we still use the term for the users. However, in test cases, including the user's term, we need to use a term of the program as well. For example, this menu or this input or very specific. So yeah, that would be proper expression. It should be written down in terms of an input and output. But to specify the test requirement to specify test cases from the requirement, we need to have traceability of vocabulary of requirements to input and an output, right? Yeah. So we can think this one is kind of an implementation activity as well. So turning design to the program, what we call is implementation, right? So still in the design part, we still use a high-level term like this, for example, GUI module, and from there are certain classes or there are certain objects. Still, they are high level, but while you are implementation, you need to bring specific class name and specific object name, or some entity that is one in design world can be divided into multiple ones, or vice versa. So there is some refinement or revision in while we're taking the implementation step. As a similar requirement is should be turned into test cases by bringing more concrete words into in here. And once we have a program and test cases, then testing activities to check whether program really satisfy the intention of the test cases. Here, test cases are written, so it's specify two things. First one is a test input, and the other one is the expected test output. Here, we can think that this one is a question, and this one is the answer. So testing activities to use a test case is using a test case to give this test input to the program and get the output of the program and check whether the output from the program really the same as expected output specified in a test case. Okay, any question here?
So actually, customers
Mm.
doesn't know that what kind of test cases they need, maybe. So
Yeah.
software engineers should make the regulation or some specific measurement to
Mm.
to satisfy that requirements to
Yeah. Yeah, that is generally true. And to make that step systematic, we first need to derive the requirements and gradually turn the requirement to very concrete test cases. That step itself is a very challenging and tricky job. So we need to make every step systematically. That is the reason why we start from requirement elicitation, and we take the design, requirement analysis, and design, and more things, so that we can fill in the gap between the one that is the desire in clients' minds to the very concrete number, value, or sequences, which is the test cases. Okay. But as you might see here, deriving nice test cases is really not an easy job. Itself is really tricky. And it is known that oftentimes this specification process takes twice time than implementation process. And I think it is also to you. So programming itself is a fun part, right? Yeah, good job. For me, when I do in a research, I always back the time that I should have a program. That is always the fun part and easy part and somewhat measurable part, because we briefly know how much time it will take to implement some feature and get 90% quality. However, what is not a fun part or chaos and heavy part is turn the 90% working program into 100% one. And that part, it will necessarily involve testing to verify that software is really correctly working. That is always tricky part and challenging part. And oftentimes we fail to achieve 100% correctness.
What about if you just choose some test cases and your 90% program doesn't fit to those test cases, and it's not simply cannot be changed by a little bit things, but if you have to change everything that you built at 90%.
That happens. That happens. So being aware of that 100%, doing a job, simply assuming achieving 90%, and doing a job to achieve 100% are different, really different, and that really matters. And that is the phenomena of one of the foundational reason that we have software engineering. Everyone can achieve 90%, and with a very funny activity. We do the prototype. We often call that as a prototyping. So we get our team like a capstone project. So let's make this product work for our demo session. We can do that. That'll be fun part. We spend time, we spend some nights, and we get something like what we do for the hackathon. We can do that. But from there, we cannot reach to 100%, obviously. It is always the challenging part is achieving that 100 or the quality of the services. The quality at the level of the making money out of it. That is a very painful part and very challenging part. Even though you like that, okay, we are almost there or not, but it is hard to reach at the point if we don't have a structure behind it. So when we sending our North Korea sent out the missile to the East Sea last night, right? So ICBM tried to carry the rocket to the very high altitude so that it can go far. So it first lift the rocket very high altitude and then it moves, because if they cannot reach to that altitude, there is a limitation to sending the rocket out to the outside. So maybe you can reach to for example, a few thousand miles without a nice crafter carrier. You can send out the 100, 1,000, 2,000, or 3,000. But if you want to send out without a carrier rocket, you cannot send out 10,000, more than 10,000. However, you have a carrier, then it starts to spend a lot of energy simply bring it to the very high altitude, and then it moves. The similar analogy we can have for the software engineering. When we are trying to achieve 100% quality, we need to spend decent amount of work, a lot of work to prepare every requirement as a form of a measurable things. And we need to have requirement traceable so that requirements will be used as a test cases. Otherwise, all the developing activities are not disciplined as well as the resulting products, and you cannot achieve. You always spend a lot of time for adding some feature in. By doing that, your program does not fit to the original expectation, so you spend a lot of time debugging it, but ultimately you cannot reach to 100% point because software is very complex and very vulnerable to frequent changes. That is the nature of the software. 그렇죠. 그러니까 출발할 때 어떻게 출발하냐에 따라서 굉장히 그 한계가 분명해요. 이걸 조금 다. So oftentimes you manage the software, large software, and you will see there is you will hit the wall, quality wall, and you think that okay, with this ill structure or ill identified requirement, we cannot go beyond that wall because we spend whole our time for changing this part and changing this part and changing this part, or dealing with the bugs and quality problems. So I want to change. Oftentimes developers say, I want to change, I want to restart the project. If I restart the project, then I will structure architecture in this way so that it'll be, so such a problem will be easily moderated afterward. Yeah. Okay. So how to do that? So here, what we have discussed so far from the discussion we have here, you will see that okay, one of the core thing in testing is this requirement, and obviously depending on the project and its characteristics, there's a lot of different requirements out there, and from different requirements we need to have a different testing strategy toward it. So so let's check this diagram. This is a V. We often call this one as a V diagram. Here, left part is the same as a waterfall model. And as I told you, even though waterfall models are something outdated technique, however, this concept about making software development as a sequence of a different activity is still alive and still makes sense. We do have a different process model for running this different activity more efficiently. However, conceptually, these flows are valid one and still important concept. So here, these are the waterfall model for the software development process. And for each step, what is emphasized in here is that each step should be paired with quality assurance activity. So each activity here is named after, it's a kind of a development process, but not a checking process, validation or verification process. However, it should be always coupled with validation or verification process. And as you can see here, okay, why is it so slow? Okay, so requirement analysis, after requirement analysis, it goes down to the architecture design, subcomponent design, and detailed design, and then it finally turn into implementation. And from each step, we derive documentation or design choices. And from there, we derive specific requirement or constraint that should be checked when, that should be satisfied when this goal has been established. So those documentation or results should be used in the verification and the validation process. So for example, we're going down in here and reach to the code some point we have a code, and from the code we need to do a unit test. Unit test here implementation is for certain very sub module, and that sub module should be tested by itself. And those sub modules are composed into a little bit larger module, and larger module should be tested according to design, corresponding design, and maybe all the system subsystem that are prepared and it merged into a system, and it should be tested according to the requirement or design decision at the moment that we decide to have this specific subsystem design. So result of this process should be used for testing process, which really finalize all the activity intended by this step. So maybe at the subsystem design, it says, okay, subsystem there should be a subsystem, this and this and this, and their interfaces are like that. Maybe that is a decision choice. You wrote down that. And from there, you say that, okay, to make this design working, this interface should meet these requirements. And there, for example, interface APIs are like these, and each API behave in this way. You document that. And that documentation are now turned into a test cases at integration step. And finally, we go to the system test. System test basically a testing with a working program as a system model. So here the inputs are something like a very specific scenario that a user can give to the system. And the output is the external behavior of the system as well. And after system test, what we mostly do is acceptance test. Here, we still use the same system, working system. Here we use the working system as well. And here we use working system as well. But the difference here is that here we check that system really behave as we documented or as we required. And validation, technically speaking, is a process that requirements are really meet the needs of the users. In that sense, these two activities are a little bit different. Maybe system tests can be done in-house or according to the requirements. But validation is at the deployment site and with the real user to check whether we really meet their needs, with ultimate goal. So technically speaking, verification is checking some program with a given specification. And validation is process to check whether specified requirements are really a valid one. In that sense, they are different. You will see this diagram a lot if you go to the industry, because every software projects are planned and scheduled according to this. We often call this one as a V diagram or V and V diagram. V and V here represent this V shape, and also it refers to the verification and validation. So they always plan this project in this way. For example, you put specific date to each activity, and you can maybe your team will specify some expected output to each activity of this diagram. So you will see this a lot. And have any question?
So from this VI model, what is the most important part to make in software engineering, software development process?
What is every part is
every part is very important, but is there any kind of most important part? So we have to consider it as most important.
Maybe later. I think it depends. Maybe for some project, design is really changing, but the other stuff are really get fast. For example, if you're reusing existing subcomponent, then basically design parts are important, but the remaining implementation is nothing more than synthesizing the existing features. or some program that it has a very simple and clear requirement yet implementation is really tricky and you need to optimize code a lot, then maybe the very low level parts have a much challenging implementation more issue. However, this one is not to emphasize specific part but to give you a overview, and here it emphasizes a flow. Let's see, so if we consider the waterfall model, then the flow is simply from top to down, right? But now you see there are two flow from one step. One is going down in here. Maybe this one is documentation or implementation. But in waterfall model, however, you now have another edge, outgoing edge, to where? To the verification process. So when you may take each step in software development, there should be two kinds of a product. One is to make for the program, and one is to make it for the test cases. You need to have always those two flow in mind. Yeah. That is, I sometimes I already gave it in. I emphasize this point in an earlier part. So every software engineer is a creator and crafter and kind of an artist in some sense, and they need to, when you are asked to do a creation, you need to always keep in mind how to show that your result is really working and it is effective and is helpful to others. You need to claim it by yourself. If it is simply a fitting problem or simply a manufacturing problem, you don't need to care about it because that is cared by the one that who give you a job. However, if it's a creating problem, then you need to show by yourself that your answer is a valid one. You see that difference. 네, 그렇죠. 그러니까 그게 이제 소프트웨어 개발하는 사람이 전문가로서 해야 되는 또 다른 역할이에요. 이게 이제 그냥 엔지니어링이면은 시키는 거에다가 집어 넣으면 되고 그건 다른 사람이 검수해 줄 수 있는데 우리가 계속 이야기하는 건 소프트웨어는 그렇게 절대 못해요. 검수를 절대 못해. 그러면 어떻게 하냐? 내 스스로 검수하는 거를 못 보이면 실패하는 거예요. 그러니까 내가 뭔가 일을 저지를 때는 이게 다른 것보다 더 좋다? 그다음에 이게 된다라는 거를 항상 마인드에, 그러니까 사장님 마인드가 있어야 돼. 그러니까 이걸 해서 이게 되면 좋고 안 되면 말고, 이거는 그렇게 프로젝트를 하면 절대 안 돼요. 이걸 갖고 내가 진짜 돈을 번다고 생각하면은 나와야 되는 퀄리티가 있거든요. 이거 갖고 예를 들어서 뭐 메신저를 만들었는데 메신저가 뭐 평소엔 잘 되는데 뭐 멀리 있는 사람이랑 뭐 메시지 한번 가는데 3초 걸린다. 이러면 못 팔잖아요. 근데 내가 그거 갖고 진짜 돈을 벌어야겠다고 생각하면은 진짜 갖고 와야 될 리퀘어먼트가 뭔지에 대해서 처음부터 생각을 안 하면은 엉뚱한 데 간다고. 그러니까 항상 디자인 초이스를 할 때마다 그걸 생각을 해서 이게 내가 이걸 결론하기 위해서 이 스텝을 간다. 이 두 가지가 항상 이렇게 같이 가줘야 돼요. 예. 그게 워터폴 모델만 보면 그게 잘 안 보이죠. 그냥 착착착 가는데 워터폴에서 디시전을 하면은 항상 이 디시전을 통해서 이 구체화를 한과 동시에 내가 이 디시전을 한 거는 이 목적을 달성하기 위함이야라는 그 두 개의 그 내 선택과 책임, 이 두 개를 항상 명기를 동시에 해야 되고 그거를 크로스 체킹하는 액티비티가 팔로우 돼야 되는 거예요. 예, 그게 VNB 모델에서 이야기하는 바입니다. Okay. Any question from the online audience? 지용, do you have any question? All right, good. Yeah, okay. These are good words, so you can check it by yourself. Okay, let me move on. Okay, and it's a Bayes' testing level, so it's a bit outdated discussion, but let's follow.
There is a question.
Okay, yeah. Oh, there's a question. So I told you that a waterfall model is a father of every process model. So basically the same. So you can think that every other process model is a variant of the waterfall model. So you can plan the verification and validation process correspondingly, even though they'll order sequence of an activities are different, but for the same unit activity, then you need to plan the corresponding verification or validation activity for that. 동의 catch. All right, thank you. Sorry, this is my Kakao also rang. Okay, so Bayes' testing level. Okay, that's good. So level zero is basically what we do for our homework. There is no difference between testing and debugging and development. We see a bug, then we start testing, and if we kill that bug, then we've identified my program is all right, bravely, and we move on. If we see another bug, kill that, and try to persuade myself that everything's gonna be all right, and keep on moving until we find that we were in a serious trouble. That is level zero, and that is all right for your homework. And if you're leaving for a day, then that'll be all right. That'll be all right. You work for a week in your company and you go away, then it'll be all right. It is nobody's problem. And I heard from funny stories too. The oil investigation. I heard from the other guys, other professor in civil engineering. In an oil investigation, they decide we will drill this land or not, and they put a lot of investigation and then decide, and then it takes years to really find out whether there is oil or not. But at the moment, everyone who made that decision is go away. If you're living in that field, then that'll be all right. But otherwise, you need to take, you need to be aware of how much responsibility of that you have as a software engineer. And then I also emphasize that software developer is not simply a worker, but they are pioneer in the company, and they are kind of an investigator. So you will see, if you're a software developer, you will first see either chance or either risk your company may face. So you need to responsibly react when you see some challenges as a software developer. 그러니까 software developer면은 그냥 단순 노동자가 아니고 이게 모르는 거를, 그러니까 굉장히 연구성이 있어요. 모든 소프트웨어 개발자는 약간 연구성이 있어요. 그러니까 소프트웨어를 개발한다는 말은 이미 지금 솔루션이 없기 때문에 하는 거거든요. 그러니까 솔루션을 만들면서 가다 보면 찬스도 보이고 위기도 보여요. 이 회사가 이걸 만들기로 했는데 여러분 막 개발하다 보니까 안 될 것 같아. 혹은 더 나은 방법이 있어. 그 여러분이 처음 보는 사람이에요. 그러니까 그에 대해서 굉장히 responsibility가 있고요. 다르게 이야기하면 그러다가 이제 이거는 회사에서 이건 계속 이 길로 하면 될 것 같은데 회사는 자꾸 그 디시전 안 한다. 그러면 여러분이 회사를 나와서 회사를 차리면 되는 거예요. 그리고 이제 거기서 이제 뭔가 새로운 아이디어는 그런 데서 나와요. 그러니까 그걸 이제 막장이라고 그러죠. 막장. 그러니까 제가 되게 좋아하는 표현인데 김훈 작가가 그 이야기를 했는데 자기 하는 일이 막장이다. 지하 갱도 끝에 들어가가지고 석탄을 캐는 일이다. 나는 그게 되게 좋은 표현이라고 생각하고, 이게 지식 노동자들은 거의 그래요. 이게 지금 뭐 돌인지 뭐 흙인지 뭐 금인지 모르는 걸 캐서 처음 보는 사람이거든요. 그 사람은 이제 뭔가 지평을 넓혀가고 있는 거죠. 이전에 없었던, 아무도 안 해봤던 일들을 하고 있는 거예요. 그러다 보면은 여러분이 굉장히 재밌는 찬스도 많이 보기도 하고요. 여러분이 그러면서 여러분한테 이제 선택의 폭이 많이 넓어져요. 그러니까 내가 그런 일들을 할 때 얼만큼 내 마음을 들여서 하냐에 따라 달라진다고. 또 약간 격길로 따라서 이야기를 하자면 계속 그 챌린징한 일들을 하다 보니까 여러분이 다른 사람한테 요구받는 일을 하는 것까지는 누구든지 할 수 있어요. 물론 누구든지 못하겠죠. 하여튼간에 그거는 뭐 할 수 있어요. 근데 그 이상의 거를 어떻게 하냐에 따라 갖고 여러분의 그 이후에 여러분의 커리어라든가 이게 달라지는 거예요. 그런 룸이 되게 많아요. 소프트웨어 디벨로퍼는. 그러니까 그거를 이제 나중에 이제 뭐 다 사회 진출할 사람들도 있고 뭐 대학원 가시는 분들도 있고. 근데 누군가 일을 시키면 다 이게 달라요. 누구한테 일을 시켜보면 결과는 똑같은 걸 결과를 갖고 오는데 그거 갖고 이제 이 사람이 어떻게 바뀌는지는 달라져요. 그거는 이제 얼마큼 마음을 들여서 하느냐에 따라 달라지는 거라 가지고 그 다르게 이야기하면은 이렇게 정신을 바짝 차리고 일을 하는 사람과 아닌 사람이 숏텀에서는 별로 차이가 없는데 롱텀에서는 되게 달라집니다. 예, 뭐 이야기하다가. So we need to keep. Okay, so we are talking about level of the testing. Sorry. So level 1. So level 0, I give you how poor the state level 0 is. And level 1, the purpose of the testing is to show that program works. So it is like a homework with a demo. You got a homework, and from the TA, in front of TA, you show that, okay, this scenario, for very sunny scenario, my program works. You use testing that way. That is better than doing no testing. Level 2, the purpose of testing is show that software does not work. So at the level 1, obviously testing does not comprehensively cover all the cases, but it covers the case that you simply assume or something that is concerned previously or something that everyone can easily identify. But for the level 2, now testing should have some comprehensive cases that testing supplement your vague your natural understanding of the software. So it'll start to count what will be the exceptional cases, what will be the soft tool cases, and what will be the possible but some ambiguous cases or something like that. So here testing is used to show that program doesn't work. It'll be like TA's job. Okay, try this input. Your program doesn't work. To point out some corner cases. Here, testing is much valuable. And ultimately, testing should go to the place. Okay, there's a level 4 as well. Okay, testing should go to the place that sorry, I'm confusing. Not to prove anything specific, but to yeah. Okay, level 2 is to show that some features are not working, and level 3 is to utilize testing to minimize the risk of the software development in a while. Here, testing is started to use as a discipline, and by using a testing, they try to assess some quality of the software as a whole, not specific bug. Here we concern about specific cases. But here we try to think about what will be the all possible cases and what will be the general assessment of the software quality. And that assessment should be is up from the testing. That level is a level 3. For example, okay, we have now, so it'll be like this one. Level 0 developer don't do a testing. Simply compile, it doesn't show any compiler error, and he believes that his program is working. Very brave. Testing 1 to show that for sunny day, very specific cases, my program is working, but has no guarantee that my program works for any cases. And level 2, it is to show that for very corner cases, program can fail. And level 3, now testing represent general execution cases. and now testing become a method to assess the quality in general. So it'll be like a matrix. So for example, usually larger software project maintain test cases together with the project source code, and they regularly run the software testing to check how far does project reach to the requirements. For example, we have a 10,000, not 10,000, 1,000 test cases, and yesterday 100 test cases has failed, but now today we have a progress, so it'll be like 90 test cases fail only. So we have improvement by 10. So test cases are measured in that way. And the level 4, which is the very ideal case, is that testing is not simply a specific method to assess the quality, but testing is a core asset of the project. So maybe at the level 3, till the level 3, there should be some specific team. Usually it is called as a QA team or quality assurance team. And there is a separate development team. So development team make a software, and then quality assessment team check whether the software is all right or not. But at the level 4, it'll be like every developer is a kind of a tester. They try to use testing as a discipline to confirm whether their activities really fulfill what they intended, and also from the design, developer count what will be the test cases to show my job really working and correct. And so testing become a daily job, and testing become a regular job together with the coding and programming. And that would be the ideal cases. Why? Then we can utilize all the developer as a tester, and all the tester as a part of the developer. And that will be the actual cases for many software company we see, like a Google or Microsoft. What I heard from the Microsoft, the one Korean engineer who participated in Microsoft operating system team, Windows team. I forgot his name, but he's now in an LG Electronics, or as a CTO, as a research fellow. And what he said is that he have a 2 PC in his desk. One is for development, and so the other one is testing. And whenever he make any change in his code, he need to update test code correspondingly. He need to run the test before publishing his change to the mainstream code repository. So he spent a lot of time regularly to the testing part, and there is no boundary and no specific distinction between programming and testing. They regularly do. That is also what I heard from the Facebook developer regularly run some testing tools to find some mistake they possibly made in the middle of the development. So they want to or have some testing system that really quickly respond to them. So such a thing is challenging. Providing such a nice testing framework is challenging. However, that is what basically the top engineer do as their development job, their development activities. And that is, I think, is the point the level 4 is achieved. 네, 실제로 그렇죠. 그러니까 purpose driven으로 하려고 하면은 계속 내가 오늘 해야 될 오케이. Who's 옹이? By the way, 옹이 이 누구지? I believe so. 옹이. it's Shin. 저거네. 현웅이네. Yeah, obviously. Yeah. Obviously, level 4 requires level 3 fulfilled. Okay. Yeah, so it's getting advanced as a level level increase. 이게 이렇게 gradually 더 좋아지는 거죠. 레벨 2하고 레벨 4 가고 이런 건 없습니다. 저 우리나라는 그런 거 늘 원하지만 그런 건 세상에 없습니다. 네. Okay, let me move on. 그러니까 이게 꼭 소프트웨어 테스팅뿐만 아니라 여러분 모든 일을 할 때도 심지어 하루를 살았는지에 대해서 어떻게 생각을 할 때도 purpose driven을 하는 게 참 좋습니다. 내가 뭘 해야겠다고 플래닝을 하면 내가 그 플랜을 만족했는지를 어떻게 알 수 있을까? 내가 어떻게 어카운트 할 수 있을까? 를 생각을 못하면 그거는 안 한 거랑 똑같아요. 네, 그렇죠. 네. 그래서 뭘 할 때 되게 오브젝트한 골들, 물론 오브젝트한 골들을 다 만족한다고 그게 내가 원했던 인텐션이 다 만족되지는 않거든요. 당연히 나중에 우리 그 이야기도 테스팅 할 건데, 예를 들어서 내가 이번 학기에 영어 공부를 열심히 해야겠어. 그래서 이번 학기에 내가 터프 얼마를 받아야겠다. 요즘 터프 스케일이 어떻게 돼요? 몇 점 만점이지?
IBT
120.
120? 그러면 만점 맞는 건 너무 힘드니까 110점만 맞아야겠다. 이렇게 계획하는 거는 좋죠. 근데 영어 공부를 제대로 안 하고도 110을 맞을 수 있어요. 근데 터플은 솔직히 그게 안 돼요. 그게 터플이 좋은 점이에요. 터플은 거의 점수가 올라가는 한은 거의 비슷하거든요. 근데 예를 들어서 토익이다. 토익 여러분이 예를 들어서 영어 공부를 열심히 해서 영어를 잘하는 사람이 돼야겠다. 한동 글로벌 유니버시티에 왔으니까 내가 그 대학교 1학년 때 토익은 여전히 1000점이죠. 우리 때는 그 토익이 990 여러분 안 쳐봐서 모르겠죠. 990 만점이었는데 예를 들어 내가 토익을 900점 맞아야겠다. 근데 토익은 아시겠지만 계속 치면 올라갑니다. 격보 타고 뭐 각종 스킬 하면 올라갑니다. 점점 900점 만족했어요. 그런다고 무슨 의미가 있겠어요. 하지만 영어 공부를 해야겠다 하고 골을 안 잡으면 그거는 definitely 아무것도 아니에요. 그러니까 necessarily 잡아야 돼요. 골은. 예. 골은 잡아야 되고 그러면은 항상 얼만큼 퍼포먼스 어웨어하게 일들을 만들어 가냐가 개인적으로는 또 좀 차이가 있었는데 팀워크를 할 때는 더 그래요. 팀워크 할 때 날짜 안 정하고 팀워크 할 때 결과물 안 정해 놓으면 팀워크는 진행이 안 됩니다. 만약 그런 식으로 진행되는 팀워크 있다면 그건 어떤 식이냐면 한 명이 다 하고 나머지 사람들은 하는 척하는 그런 팀워크밖에 안 되죠. 여러 사람이 진짜 같이 하려고 하면은 이게 서로가 생각하는 꼴이 어떻게 같은지에 대해서 객관적으로 이야기할 수 있는 방법에 대해서 늘 생각을 해야 돼요. 그러니까 그렇습니다. 그리고 그래서 소프트웨어 엔지니어링은 사실 일을 어떻게 잘하냐에 대한 이야기라 가지고 공부를 하면 할수록 그 여러 가지 인생의 지혜들에 대해서 많이 생각을 하게 되는데 어려워요. 네. Anyway, I need to soon wrap up the class, so I will spend 10 more minutes. Okay. So let's go back to this diagram. So we talk a lot about why testing is important, and let's talk about then how we can achieve quality testing from this diagram. Let's systematically think. Which test cases should we use in our software testing? It depends. It depends. So there are many strategies to reliable testing, test cases, quality test cases. Quality test cases here, I mean a set of input and output pairs that sufficiently check the correctness of the software in generally speaking. But what if it is the sufficient test cases then? It depends on the characteristics. So people have found many various strategies, and each strategy has its emphasis on some characteristics of the target program. So here I want to give you a big picture of different software testing strategy so that you can understand their variations, and also you can understand the commonness here means that testing is a very requirement driven job. Requirement driven job here is, I say, for some project, depending on the project, the important parts are different or challenging parts are different, and depending on that the important feature, depending on what is important in the project, the testing activity shape in different ways. So I first here give you a big picture. So ultimately, what testing needs wants to have is this one. So maybe some of you know the practical logic and some of you are not familiar with the practical logic. What about you? Are you with the practical logic? I surely say you learn it from your discrete math course, don't you?
Taking it.
You didn't take it.
Yeah.
What about you?
I got pretty bad score.
Okay, so that's okay. Yeah, that'll be all right. Yeah, that'll be all right. And okay, let me elaborate on the notation. So here, you can think that this one is a for or. So let's give you.
For all test cases.
Yeah.
In,
I turn this into a programming language code-like structure. It's for all, for every input t. PT basically return the output of the program by receiving input t. Should be the same. Should be the same as st. St here I intend expected output of the t, and s here I say it's a spec. Something like that. So if they are not the same, return false. Otherwise, return true. That is what basically this statement claims. So that is the ultimate goal. But the problem here is that even for a very small program, there's a millions of tons of astronomical number of the input possible. For example, you have an integer, and integer bring what? 2 to the 32 different values. And if your program receive 2 integer input, then already you need to spend whole of your lifetime for validating for checking every input. And if your program had a receive a 3 integer, then how many cases are there? And you need to deliver your testing task to your child. And ultimately, Jesus comes and your project will fail. 예, 그렇게 되겠죠. 이게 불가능합니다. And there are many reasons why this one is impossible, but heard about halting problem, undecidability. So I teach this in this semester discrete math course, and in this discrete math course, in discrete math or programming language or compiler, you can learn that theoretically this one is impossible. That has been proven. 예, 이게 이론적으로 불가능해요. 일반적인 프로그램에 대해서 모든 입력에 대해서 프로그램 동작이 맞는지에 대해서 검증하는 게 불가능하다는 게 증명이 돼 있어요. 재밌죠? 네. 현웅이는 알아야 되죠. 왜냐면 현웅이는 지금 디스크릿 매스 코र्스를 지웅이랑 같이 듣고 있으니까 그 둘이는 아마 알 거예요. 네. 지웅 카피. Yeah, take. Sure thing. Okay. We essentially we got to do some abstraction because this one is desirable but unachievable. Then how can we solve this problem? So there are many strategies. So let's first think about random testing. Random testing is doing this one. So here, Ri is a subset of an I. We pick some very small subset from an I and assume that represent whole I. That will make sense especially for some domain. For example, you're thinking about uh, engine controller, thinking about an engine control in a vehicle, and it receives some signal numbers from sensors. But from the input sensor input, we can find some statistical distribution that explain the tendency of the input. And from there, you can randomly sample some representative cases. And you can assume that really represent the whole cases. 그럴 수 있겠죠. 예를 들어서 이거는 확률적으로 어떤 모델을 따른다고 생각을 하고 여러분이 그 모델 안에서 신뢰도를 계산을 하면서 몇 개를 픽할 수 있어요. 굉장히 작지만 그게 전체 디스트리뷰션을 잘 표현하는. In such a case, you don't need to do all things, but you need to do pick some samples and do the testing with the sample, and that'll guarantee you pretty reliable result. 실제로 그래서 이게 그런 컨트롤 도메인 같은 거에서는 많이 합니다. 그리고 그 모델링을 어떻게 하고 그다음에 그 이제 프로바빌리스틱 모델을 알 수 있으면은 뭐도 할 수 있냐면 테스팅의 신뢰도도 알 수 있어요. 그러니까 이 프로바빌리스틱 모델을 따르지 않는 인풋 경우의 수는 얼만큼으로 제한시킬 수 있으니까 그러면 그 테스팅을 이만큼 했으면은 몇 퍼센트의 경우에 대해서는 우리가 테스팅을 했고 몇 퍼센트 경우는 테스팅을 못했다 이거를 알 수 있거든요. 그래갖고 테스팅 한 다음에 우리가 신뢰도가 얼마인지 이런 것까지 이야기할 수 있어요. 이제 소프트웨어 reliability 하는 사람들이 많이 하고요. 뉴클리어 파워 플랜트 이런 거 하시는 분들이 이런 거 많이 합니다. 그래갖고 테스팅 얼마큼 늘리면 얼마큼 신뢰도를 올릴 수 있나 이런 거 막 하는데 그것도 재밌어요. However, there are rare cases that the input have a nice random distribution, and we know what's the distribution of that input. 뉴클리어 파워 플랜트 같은 경우는 열심히 연구하면 이제 입력에 들어올 수 있는 거를 이제 stochastically 모델링 할 수 있는데 그렇게 할 수 있는 도메인은 굉장히 적죠. Then it is impossible for us to find nice representative cute sample. Then so that okay, what about simply bring a random number generator and pick the number? That doesn't guarantee anything. 이죠. 그냥 임의의 거에다 그냥 뽑으면은. In such cases, RI is not representative. Then you can easily faked by the random testing result. 랜덤 테스팅에서 픽했어. 근데 아무 말도 못 해주는 거예요. 예를 들어서. 예를 들어서 여러분이 뭐 랜덤 넘버 제너레이터 그냥 해서 인티저에 2개 입력받는 프로그램에 대해서 했어요. 여러분이 랜덤 넘버 제너레이터 해서 랜덤 넘버 제너레이터라서 10시간 돌릴 때 아무 문제 없어. 잘했다. 했는데 알고 봤더니 여러분이 랜덤 넘버 제너레이터를 그냥 써갖고 랜덤 넘버 제너레이터가 그냥 양의 점수만 뽑아줬어. 근데 음의 점수를 받을 수 있었던 거죠, 여러분 프로그램. 그러니까 여러분이 생각했던 모델이랑 실제가 다르면은 아무 의미가 없어요, 테스팅. So it has such a limitation. So what will be the ultimate? So then what will be the other possible ways to have a more systematic testing result? And one possible way is that here we can divide, if we know, if we have a knowledge of an I a little bit more, so that we can divide the I into some subsections. Then from the section information, we can pick particular number from each section and use that as a representative cases. And we often call that as a input partitioning based testing. 근데 이것도 뭐가 있어야 되냐면 input space에 대한 그 지식이 있으면 이게 할 수 있어요. 예를 들어서 input이 뭐 usually the representative case of input partitioning is the web pages. If you sign in the web pages, 여러분이 웹 페이지 사인을 할 때 보면은 there is a what you call that, some combo box or radio box, so that you pick whether you are male or female, or you pick your occupation or something like that. And there you know that okay, these are the all possible input cases, and they can be partitioned into these. Even though there are many different cases, however, if we want, based on our needs and based on our test amount of testing budget we have, you can systematically pick some diverse test cases. 그래서 combinatorial testing이라는 게 많이 그런데 예를 들어서 그런 콤보 박스 여러 개 있어요. 비즈니스 로직에서 그런 게 많이 생겨요. 그러면은 이런 거 할 수 있어요. 최소한 콤보 박스에 한 번씩은 다 체크되게 이제 입력을 뽑고, 그러니까 예를 들어서 남자고 예를 들어서 학생이고 포항에 살면서 여러분 뭐 있죠? 포항에 살면서 우리은행을 쓰는 사람이다. 예를 들어 우리은행을 쓰는 사람이다. 이런 식으로 이제 테스트 케이스를 만든다고 생각하면 이런 걸 할 수 있죠. 테스트 케이스 많이 갖고 오되 포항 그러니까 각 도시별로 한 번씩 검사가 돼야 된다. 각 성별별로는 한 번씩 검사가 돼야 된다. 이런 식으로 인풋 스페이스에 대한 지식이 있으면은 한 번씩 그 각각 다른 섹터에 들어가게끔 인풋을 픽할 수 있어요. In such a testing strategy, we call partitioning testing, and there are many researches out there about picking a nice representative sample cases. And one of the recent advanced technique is what we call combinatorial testing, because oftentimes input is defined as a combination of different primitive values. So how to pick representative and comprehensive yet small sample test inputs. However, what if we don't have such a knowledge, or input is so large? For example, input simply receive a sequence of a string, sequence of a bit. Then it is hard to make a nice partition out of it. Then we need to think different entities we can utilize for the testing. For instance, then it'll be good to look into the design part. And from the design typically divide the program into many subsystems. And from there, we can have some knowledge. For example, program P is composed of a subcomponent D1 and D2 and Dn. If we can partition the program into many chunks in that way, we can utilize this one. Okay, so we may find some input for that test each sub program at least once, or we can have a different criteria. But as long as that criteria is the base on the model of the program, we call such a testing strategy as a model-based testing. A typical example is a GUI testing. In GUI testing, we can model the GUI interface of our app, for example, mobile app, as a state chart, right? Can you see that? 스테이트 차트로 표현할 수 있겠죠. 예를 들어서 히스넷 같으면 뭐 다음에 프론트 페이지가 뜨고 뭐 출석을 누르면은 이런 메뉴가 뜨고 그 중에서 이걸 누르면 어디 갔다가 되돌아오기를 누르면은 다시 앞으로. 그러니까 그거를 스테이트 차트 같은 걸 표현할 수 있거든요. GUI 모델을. Then from the state chart, we can see that okay, there are, for example, 20 different paths from the front page. We know such knowledge on the program structure, and try to give some number of test cases for each different GUI path or something like that. That would be a systematic ways to enumerate comprehensive cases of the program, comprehensive behavioral case of the program, and that'll be nice guidance to find meaningful sample of test input. Requirements typically consist of many subparts as well, especially requirements are big enough. Then it'll be good to have requirement to different pieces, and for each piece of the requirement, we need to find enough number of the tests, so to identify meaningful subset. Such a approach is what we call specification-based testing. Here, what is all the test case generation or test case creation activities are driven by the specification and their structures. Finally, in many cases, you don't have any concrete description for the model or the requirement specification. That is a usual cases. 그렇죠? 이것도 다 없을 때가 사실 대부분 많아요. 일단 인풋에 대한 지식도 따로 없고 디자인 리퀘어먼트 다 애매할 때 있어요. 그럼 어떻게 테스팅하냐? You can use program structure as a guidance to enumerate different cases. It is like unsupervised learning. Supervised learning is comparing something, learning something against, learning some pattern against some, what you call that, corpus, right? Some external entity. However, unsupervised learning is to learning something by minimizing some tendency within the uh, target object. Similarly, when you test the program, you can utilize the structural program as a guidance. How? The easiest one, trivial one. Each code should be executed at least once by some test cases. 그렇죠? 그러니까 here we can easily find the structure of the program if it is given from the source code. Then we can divide the program into many pieces of the code and try to derive test cases for each pieces. However, oftentimes it is a very untrivial to find specific test case T that associated with specific part of the program. For example, what will be the input that will execute this part? Mostly that is untrivial. So it is a challenging. However, if we somehow need to have that kind of a knowledge, it will be very effective and very powerful methods to derive test cases in that way. 예, 입니다. 예. And so this approach we call as a structured testing. And honestly speaking, recent advances a lot in the software engineering is on the structured testing. Why? We usually don't have a model or a requirement in many software software development projects. If it is not mission critical ones, then only information that we can use for the program behavior is the source code itself. And recent advances in program analysis and many analysis tool can do this job. What? Finding specific input that associated with a specific target source code piece and utilizing that technology to generate the test case is really, recent interest of the researchers and now many industry try to try to bring this kind of a technology to their project setting. So this is a big picture. Okay, so but the remaining slide of this lecture try to give you some examples for each different strategy, like random testing, structure testing, specification testing. But I will cover that part in this Friday. And I will announce what time the online lecture, the second online lecture will be given. I'm not sure of, because I cannot sure about anything for the Friday schedule anyway. But if it is fixed, I will announce, and then I will continue from this slide. So do you have any question from the audience? If you don't have questions, please say no. Good. Okay, then see you Friday. Okay.
감사합니다.
Very much.